Now, we have seen square root in the past. Square root is simply a radical. So what do we mean by that? So suppose we have square root of 4. We all know that square root of 4 is 2, plus or minus 2. But why is it so? The radical can be written as 4 raised to the power of 1/2. We know 4 is a perfect square, so I can write it as 2 squared raised 1/2. But I can also write it as minus 2 squared raised 1/2. If we use the properties of exponents, I should multiply those two. So 2 raised 2 times 1/2. The 2's would get cancelled. I have 2 raised 1. So the answer is 2. Over here, we still have to multiply 2 and 1/2. So minus 2 raised 2 times 1/2. The 2 and 2 will get cancelled. I'll have minus 2 raised 1. I'd get minus 2. So when I take the square root of 4, I have plus 2 and minus 2. Hence, we say the square root of 4 is plus or minus 2. The key idea to note here is how I went from the radical to this power 1/2. By all means, the proper way would be to write it as 2 raised square root of 4. The radical with that 2 sign. But we use square root quite often that we don't even specify this tiny little 2. But for every other case, we have to specify what root we're talking about. So for instance, that will be the cube root of 8. So that is equivalent to saying 8 raised 1/3. That is the 4th root of 16. It is equivalent to saying 16 raised 1/4. Sixth root of 81, it is equivalent to saying 81 raised 1/6. In general, the nth root is square root, the root sign with n. And it is equal to a raised 1/n. So that is what we mean by a radical. I already mentioned the nth root is simply the root sign with that tiny little n. And that is equivalent to saying a raised 1/4. Square root of a positive number is real. the answer will be a real number. But square root of a negative number is imaginary. We will encounter this later on in chapter 8, but you do have to keep in mind, anytime you take the square root of a negative number, you're not going to get a real number. So if you plot it in the calculator, you will see nothing. You'll just see a blank screen, or it might give you an error depending on the calculator. You have to change the settings to see an imaginary number. In general, having difficulties here. Anytime you take an even root of a negative number, the result is going to be imaginary. So, but square root is the best example. If we have a positive number, there isn't any issues at all. Also, when we take an even root, result in plus or minus signs. It could be positive or negative. But when it comes to an odd root, it's always going to depend on the sign that's inside the radical. So odd roots work for any real number, in the sense it can be positive, it can be negative, it can be zero, it'll just work. The answer would be a real number, and square root of 0 is 0. Do not forget that. Okay, so here is an example. Suppose we want to find the square root of x raised 8. The very first step is to recognize that this is equal to x raised 8 raised 1/2. Now we could use the rule of exponents and multiply 8 with 1/2. To get 8 times 1/2. The 2 goes into 8 4 times. So we will have x raised 4 times 1, which is 4. With enough practice, some of you needn't even try to write it in terms of the power 1 over 2 or 1 over 3. But all it requires is some practice. Now, before I do the next problem, I want to give some important properties square root of 1 is plus or minus 1. Cube root of 1 is 1. Cube root of negative 1 is negative 1. If I have two numbers, A and B, and I can either add them together or subtract them, and if I have their nth root, I cannot write it as nth root of A plus nth root of B. This is a mistake I've seen students, senior students in college make. So don't make this mistake. This is completely wrong. So you cannot split a radical that has terms in sums or differences. But what is doable? If I have the nth root of A over B, I can split and write it as the nth root of A divided by the nth root of B. In a similar manner, if I have the nth root of A times B, I can write it as nth root of A multiplied by nth root of B. So the only times when you can split a radical is when numbers are in product or in division or quotients. So here is an example. So square root of 16 over 16 times y raised 6. Now I can write this as square root of 16 times the square root of y raised 6. You always try to write the number or expression inside the radical in powers of the root that you're looking for. Here, I'm trying to find the square root, so I should write the number inside the root, 16, as a square of some other number. Well, 16, I could write it as 4 squared. Similarly, I want to write y raised 6 as a square, so y cubed squared. And I'll show you the formal way, and then there's this informal approach that I explained. It's easier to understand. So the formal way would be to have 4 squared raised 1/2 multiplied by y cubed squared raised 1/2. When we multiply the 2 and 1/2, we will get 1. 4 raised 1 is 4. When we multiply the 2 and 1/2 there, we will get 1, so y cubed. So the answer is y cubed. Now this is the informal way. I always tell my students, if you have the nth root and you can write the number inside the root or the expression inside the root in terms of the nth power, I do this squiggly line and get rid of the root and the radical. That'll give you just A. So I could use the same approach, squiggly line there, squiggly line there. So the root and the square directly will get cancelled, and I would end up getting 4 times y cubed. So you can see that you get the same answer without going through the entire process of writing them out. The key always is to express the number or expression inside the radical as a power of the integer specified in the radical. So if it is a square root, the expression inside the root must be written in terms of the second power. If it's a third root, you have to write the number inside the radical in terms of a cube or a third power. So we can split the radical because the terms are in product. So square root of 64 multiplied by square root of y raised 20. Now, since it is a square root, we want to express the number and the expression inside the root as a perfect square. 64 is simply 8 squared. I can write y raised 20 as y raised 10 raised to the power of 2. So the root and the square will get cancelled. So we simply end up having 8 multiplied by y raised 10. It's 8 times y raised 10. Now we have cube root of x raised 15. So since we have a cube root, our objective must be to write the expression inside the root as a power or in powers of 3. So I can write x raised 15 as x raised 5 raised to the power of 3. Because if I express it in a cube, then the root and the cube will get cancelled. So those two would go away. I will simply have x raised 5 as the answer. What if we had a negative number? So I could write negative 27 as negative 1 times 27 times the x raised 9. Since they're all in product, I can split each of them. Cube root of negative 1, cube root of 27, cube root of x raised 9. I wrote in the properties that cube root, or in general, any odd root of a negative number, it's simply negative. So I get a negative out in the front. I would like to express 27 as a perfect cube of a number. So 3 cubed. I want to write x raised 9 as a cubed. X cubed raised 3, because 3 times 3 would be 9. It'll correspond to that number there. The root and the power will get cancelled. So we would simply have the negative multiplied by 3, multiplied by the x cubed. So the answer is negative 3x cubed. So, as always, since it is a third root, we want to write the expression in powers of 3. But before that, I'm going to split that negative 64 as negative 1 times 64. Since the terms are in product, I can split the radical. Cube root of -1, cube root of 64, cube root of x raised 6. Cube root of -1 is -1. Cube root of 64, I could write 64 as 4 raised to the power of 3. I need a perfect cube multiplied by x raised 6. I could write it as a power of 3. The root and the cube will get cancelled. The root and the cubed will get cancelled. So we will end up having -1 multiplied by 4 multiplied by x squared. So the answer is -4x squared.